Welcome viewers. We are now going to begin with the module number 18, which is on applications based on Gauss-Markov theorem. Gauss-Markov theorem states that in an ordinary least square methodology, the estimators actually follow the blue property, that is the best linear unbiased estimators. So based on this Gauss-Markov theorem, we will take an applied example based on the real life data, and we are going to interpret the estimation results accordingly. So in this particular regression model, we consider a data on y and x. So it is a bivariate regression model where y is regressed on x. Y basically is a data collected from World Development Indicators, that is World Bank, on the inflows of FDI, and it is expressed in terms of percentage. So the data is collected from the World Bank, which states on FDI inflows, foreign direct investment inflows, for a particular country, say India, and X is GDP per capita, which is also expressed in terms of percentage. The time frame comes out to be 20 years. The source of the data is from World Development Indicators, and for pacifying the fluctuations of the variables and also taking standard error, the variables are converted to log. So based on the transformation of the model, it is basically a log linear model, and all the variables x and y both are considered in the logarithmic transformation. This boils down to a bivariate regression model, as we can observe in this slide. It is said ln FDI is equal to alpha plus beta ln GDP plus error term. So when we refer to ln FDI, it is the dependent variable, ln GDP is the independent variable, and we want to trace out a relationship between ln FDI and ln GDP. Accordingly, alpha and beta are the population parameters which are needed to be estimated. An error term is considered as the omitted variable term, which is the random term in an econometric model. So we observe that alpha will be given to the 0 even if all the variables are taken care of. But if alpha is non-zero, then the value of y will be equal to alpha if we consider x is 0. So it is basically a term which is autonomous, independent of all the other factors. Beta, as usual, is the slope, which also explains the marginality in this equation. That means if there is a per unit change in the level of the GDP, how the FDI will get the effect, that is also captured by the beta. And finally, in order to apply the OLS model, the error term must follow the OLS assumptions. So whenever we want to regress this particular model, we will look into some of the regression output, and then we shall also put our equal emphasis on the regression diagnostics to accept the OLS methodology fully. So in this regression model, we have ln FDI is regressed on ln GDP, and alpha and beta are the respective population parameters which are needed to be estimated based on the sample observations. And this is done by minimizing the sum of squares or using the OLS methodology. Now we go by the stepwise analysis of regression output. Because whenever we do this regression output in whatever software we do this exercise, we shall get 3 different steps as per the output goes. So first of all, in the step 1, we want to claim about the overall significance of the model. That means all the coefficients are significantly affecting the dependent variable or not. That will be understood by this null hypothesis. So we mean by the null hypothesis is this, that all the intercept and the slope coefficients, in this case the intercept is basically the alpha and slope coefficient is basically the coefficient of ln GDP, whether they are having any impact on the FDI or not. That comes up as the null hypothesis. But when we go for the alternative hypothesis, we say that it is having an impact. So based on that, we are going to design a test statistic, which is the F test, and because it is given by the ratio of ESS, explained sum of squares, divided by RSS, or residual sum of squares. And based on our decision rule, we say that if the computed value of the F stat is exceeding the table value of F stat, then the null hypothesis gets rejected. So this is particularly very important when we go for the overall significance of the model, and so we apply the F statistic, and accordingly we go for the goodness of fit measured by the R square. So as we move on to the empirical results of step 1. So in step 1, we actually observe that by the data of 20 years on these two variables and running the OLS method, we get F statistic 34.54, and the p-value or the level of significance is given within the bracket, which is 0.00. So this level of significance is less than 0.05. So according to our decision rule, the null hypothesis gets rejected. So there is an overall significance of the model, and so the beta coefficient and the alpha coefficient significantly affects the ln FDI. Moreover, we get R square 85%. This is also a very important indicator of goodness of fit, because 85% of the variation in the dependent variable, which is ln FDI, can be explained by the independent variable ln GDP, and the 15% remains unexplained. So whatever has been captured by the residual sum of squares, or whatever has been captured by the error term or the omitted variables or the random factors, that is only 15%, but the majority percentage is being captured by the independent variable taken in the study, which is ln GDP, and that amounts to 85%. So this model basically has a very, very acceptable goodness of fit, and so we can proceed for the interpretation of the regression output. So in the step 1 in any econometric regression exercise, first of all we comment on the overall significance of the model. For that we check the R square, and then also we go for the F statistic, which is basically the statistical significance of the model, and thereby we can comment whether it is 85% or it is near to 100%. Then only the explained proportion will be definitely higher than the unexplained proportion. Now we move on to the step 2, which comprises within the OLS regression output any kind of modeling. So when we go for the step 2, the OLS output actually reports us ANOVA, which means analysis of variance. So in any regression exercise, we have the total sum of squares, which means deviation of the dependent variable from its mean, is decomposed into explained sum of squares, which is explained by the independent variables or the explanatory variables taken, and the remaining portion is the residual sum of squares, which is captured by the error term or by the factors which are not considered in the study. So in this case, we have the following components. The first component is referred as ESS, which is explained sum of squares. In order to get a proper test statistic, we need to also take care of the degrees of freedom, because degrees of freedom is number of explanatory variables or number of unknown parameters to be estimated. So in this case, the number of unknown parameters is k minus 1, because only one independent variable is there. So k minus 1 happens to be the degrees of freedom. And when we divide ESS by k minus 1, we get the mean square error. So here we are indicating mean square error as MSE underscore 1, which means ESS divided by the respective degrees of freedom. Then we have the residual sum of squares, which is RSS, which is captured by the error term, and that is also divided by the respective degrees of freedom, number of observations, minus number of variables to be estimated, which is k. So n minus k. So depending on that, we get mean square error, which is MSE underscore 2. So MSE underscore 1 and MSE underscore 2 are the two different mean square errors. If we take the ratio of these two, we get the F statistic, which is already being reported under our overall significance. And again, by confirmation, we need to report the F statistic, which follows n-1 degrees of freedom. Because if we add up k minus 1 plus n minus k, then minus k plus k getting cancelled out, and we end up with n-1 degrees of freedom. So what is the objective of this ANOVA? ANOVA, or analysis of variance, confirms the goodness of fit of the model, and fully we take the decision whether the model is finally acceptable or rejected. So in this particular case, we get these particular values as per the ANOVA goals. First of all, we have the ESS, which is explained sum of squares, 52.56. The degrees of freedom is 2 minus 1. Why 2? Because A and B, or alphas and betas, are the two unknown population parameters which are to be estimated, and minus 1. So after subtracting, we get 52.56 divided by 1, and we get the value of MSE underscore 1. Similarly, we have the residual sum of squares, and we divide by the respective degrees of freedom, which is number of observations 20, minus 2, which is alphas and betas to be estimated, and we get 1.908 as the MSE underscore 2. So by taking the two ratios, we get the F statistic, which has the degrees of freedom 1,18. 1 because of explained sum of squares, ESS, and 18 because of residual sum of squares, which is 20 minus 2. Now we have the table values of F. These are given as respective level of significance, either at 10% or at 5%. But whatever be the level of significance, we observe that the computed value is 27.55, which is much higher than 8.29 or 4.41. So at all levels of significance, the tabulated value of F, which is F star, is exceeding, which actually rejects the null hypothesis, and we say that definitely the LN GDP per capita is a significant factor in explaining the variation in LN FDI, and it is significantly affecting LN FDI, and so the overall significance of the model is there. So we have actually commented based on the first two steps about the acceptability of the model, and so we can proceed for the further estimation output, because these are the two pre-qualifications that needed for any regression output to proceed on. After the overall significance of the model, it is very necessary to go for the interpretation of the regression output, that is the estimated equation, which is the sole objective of this entire exercise. So in this particular equation, we observe that ln fdi hat, which is the predicted value of the dependent variable, is equal to alpha hat plus beta hat ln GDP, which means the predicted value of the independent variable. Now, as per as our numerical results, we observe that alpha hat is 2.24, which is the estimated value of the intercept, and the beta hat value is 0.45, which is the slope coefficient of this equation. This 2.24 will always be constant even if the GDP is 0, because 2.24 is autonomous and it is the constant intercept term. But when we refer to 0.45, it means it is the slope coefficient, which means that if the ln GDP rises by 1 unit, then ln FDI hat will be rising by 0.45 units. So that means it is measuring the magnitude and also explaining the direction of the relationship because of the plus sign. Now we move on to some of the diagnostics. So first diagnostic is the test for heteroscedasticity, which means that the residual of this estimation exercise should not have changing variance as per the OLS assumptions. So for this we need to check this test, and for this we mention the null hypothesis as residuals have constant variance, which should be as per the Wheeler's assumption. An alternative, it's not constant. So the chi-square value is given by 34.32, and we can see the p-value is much higher than 5%. That means it is basically 21%, and we can see that the null hypothesis is accepted. So as per the heteroskedasticity is concerned, this test statistic confirms the presence of homoskedasticity in the residual errors, and thereby we can proceed for the other diagnostic test. Now we go for autocorrelation. Since this is a time series data, it is very evident that the errors might be correlated with each other. So in order to do that, we go for the autocorrelation and we go for the null hypothesis, which says that there should not be any serial correlation among the errors. So whatever errors we have considered, they should not be regressed upon each other or dependent on each other. That is, error of today should not be dependent of the error of yesterday. So in order to do that, we go for the Darwin-Watson test, and again we observe that the value is 1.95 less than 2, and the p-value is 0.21. So again we interpret that the null hypothesis is accepted, which means that the errors are not serially correlated with each other. This is very important to understand because autocorrelation, if exists, we cannot proceed with the OLS. We have to check for autocorrelation and then we can go for the estimated output. Now we go for the multicollinearity. Now in this case, the multicollinearity problem may not be so much effective because we have only one independent variable, which is ln GDP. But if there is a multicollinearity problem, then we can see that the correlation among the independent variables will be taken care of. And if we consider other independent variables in the study, then the variation inflation factor is 2.11, which should be less than 10. And so this problem can be taken care of. So this again refers to the hypothesis, which means no correlation among the independent variables. So as of now, for heteroskedasticity, the null hypothesis is accepted. That is the residuals of constant variance. For autocorrelation, there is no correlation among the errors, which means that there is no autocorrelation problem. And also multicollinearity may not be the effective instrument here because it's a two-variable model, but otherwise multicollinearity, if present, has to be corrected by dropping the variables. And then we go for the omitted variables. Because by omitted variables we mean that any other variable captured in the error term should not be related with the dependent variable, and so that comes in. So here also we go for a test called Ramsey test, which is the specification test. And again we accept the null hypothesis that yes, the model has no omitted variables. So finally, keeping in all of them, based on the post-regression diagnostics, we can say that the OLS methodology is appropriate because all the OLS assumptions are valid, because there is a constant variance, there is zero autocorrelation, there is no multicollinearity, and also no omitted variable in the model. So based on all the four, we can see that the OLS methodology can be proceeded or can be interpreted. Now we move on to the another dimension of the Gauss-Markov theorem, which goes for constraint optimization approach. Because whatever optimization technique we do, we have to take care of the feasibility of the model and the feasibility of the structure. So here we go for a model which has two goods x and y, and an utility function is given as xy. So what is being done? That xy is considered to be the commodity bundles that are purchased. The budget is given by the $400, and the prices of the items are given as px10 and py20, and we are asked to find out the optimum consumption bundle, and that is how the Lagrange method comes in. So in order to do this, we have to set an objective function which is maximization of utility as usual, and then we have a constraint which is money income of the budget 400, 10x plus 10y are the respective px into x plus py into y, and x and y must be non-negative. So given this budget equation, our objective is to maximize our utility. So in order to do this, we obtain the Lagrangian function, which is xy, plus this is the Lagrangian multiplier given by this portion as 400 minus 10x minus 20y. As we go for any estimation exercise or any kind of maximization or a minimization problem, so for any optimization problem, we go for the first order condition and setting the derivative equals to 0. So by setting the derivative equals to 0, we get x equals to 2y from the equation 1 and 2, because these are definitely del L del x 0, del L del y 0. And then we have del L del lambda, which is based on the Lagrangian multiplier. So from equation 3, we can see that 400 equals to 10x plus 20y. And by substituting equation 4, we can get the absolute units of x star and y star, which are 10 and 20. And by putting in the utility function, we get u max as 200. So this is basically a simplistic approach of an optimization exercise done within the framework of the Gauss-Markov theorem, provided x and y follows all the normality assumptions, and also these are in tune with the assumptions of this theorem. So this goes back to the final summing up of this particular module, which says that the OLS methodology is appropriate and we can go for the interpretation of the output if the OLS assumptions are accurate and valid. That's very important. OLS output predicts the model. That is also very important, because the predictive model is actually our objective of any estimation problem. And finally, we go for the constraint optimization approach that is in tune with the feasibility. And we observe that in case of this approach, we have x and y which are obtained in the physical units, and that is how the constraint optimization is being done. So in this particular module, we have actually discussed upon the application-based approach of the Gauss-Markov theorem, taking care of the real data and also interpreting the real output.